So we have looked at what gateways are available, tier 0 and tier 1 in NSX. We've looked at the components of those gateways, the distributed router that lives everywhere, and the service router that lives only on an edge node. And that edge node and the edge cluster that it goes in, that's what this video is all about. We're going to talk about the edge nodes. We're going to talk about why we have them, what they do, how do we look at them, how do we build them, how do we deploy them, and all that kind of stuff. So that's what this video is all about, is the edge node and the edge cluster. Now, the edge node is necessary. It's necessary for a great number of things. It's the thing that provides all the compute resources for the service router component of a tier 0 or a tier 1 gateway, right? This is where my uplinks live. This is where my VPN endpoints and my NAT processing and firewall and advanced threat prevention processing all happens, is in the edge node. Now, the edge node is a full transport node in the context of NSX, meaning that it's got tunnel endpoints. It terminates overlay tunnels. It participates in logical switching just as well as logical routing. We've got to be able to get traffic to the edge node in order for the edge node to process things. So that's a big deal here, right? It's a very, very important thing that we have, this edge node as a transport node. Now, we're not consuming edge nodes independently. We are consuming an edge cluster. And an edge cluster is simply an object that includes one or more edge transport nodes for consumption by NSX objects. The edge cluster can have as many as 10 edge nodes in it. And those edge nodes, if you want, can be divided up into fault domains or failure domains. Now, the failure domains are configured only by the API at this point, but you can configure them maybe to make things rack aware, where, maybe I've got this edge cluster like we have on the screen. I've got 4 edge nodes. 2 of them are in rack 1 and 2 of them are in rack 2. Well, maybe I set up some failure domains to encompass the edge nodes that live in each rack, so that NSX knows that when it needs to place an active standby service router, it places the active in one failure domain and the standby in a separate failure domain altogether, instead of just on another edge node in the cluster. So failure domains, those give us some additional availability and flexibility in what we're doing. Now, edge nodes oftentimes are going to be virtual machines, but that's not the only form factor available. We can also deploy the edge appliance software onto a physical server if, for example, I have very, very high bandwidth requirements. And we'll talk about some of those as we continue through this video. So if we were to look at a virtual edge, they come in a number of different form factors and sizes. And you can dig into the installation guide, into the system requirements section, and that talks about the different form factors, kind of like we have them laid out here. And it also talks about use cases. And we can look at the small edge node for lab or proof of concept type deployments, where I have minimal throughput, that I have to worry about, and maybe my services aren't very heavily used, if at all, or just functionally testing, or whatever we may be looking at. But this is for real small scale testing sort of stuff. Now, the medium-sized edge, this is where we get into production deployments. But the medium edge is going to have limited utility in that it only supports about 2 gigabits per second worth of throughput. That's not a ton, but it's enough for some environments. We can move up from there to the large-sized edge. And large-sized edge covers up to 10 gigs throughput, right? It can kind of saturate a VMXNet 3 virtual NIC if we so desire. And then this is where most of our production deployments really start when we deploy edges. The extra large edge doesn't get us any throughput benefits, but it does give us quite a bit more compute resource available for additional services, advanced threat prevention, things like that. So each of these form factors does have a use case. There's a reason we have these. Now, to deploy an edge node, most of the time, we're going to deploy a virtualized edge node right through the NSX UI, at which point most of this stuff really doesn't make a difference. But there are cases where we're going to deploy the virtual edge using an ISO image through maybe a Pixie environment, or directly using the virtual appliance, the OVF file. There are cases where maybe I have other automation set up that's driving the deployment of these edge nodes. Now, if I'm using those, then I have to think about the fact that my password needs to be SHA-512 encrypted, and that my host name has to be good, and the fact that these are virtual machines, they're going to have VMware tools deployed automatically, but I'm not going to change those. I don't want to remove, replace, upgrade anything. Just leave VMware tools alone. There's some requirements we have to meet here. Now, when I deploy an edge, a virtual edge, specifically a virtual edge, I'm going to deploy a virtual edge that's going to have 5 virtual NICs attached. The first virtual NIC is always going to be claimed by the operating system for management, right? That's going to be connected to my management port group on my distributed switch, and that's dedicated for management, right? So network adapter 1, as it would be labeled if you look at the actual virtual machine, that's going to be connected to my management port group. And that leaves me 4 other virtual NICs for my data path. And that gives us a lot of flexibility in how we're going to build NSX, how we're going to create our NVDSs on the edge node. I could set up something like what we're showing here, where I'm using multiple NSX virtual switches, one for my overlay network with a couple of NICs there for traffic balancing, and then maybe a couple of different virtual switches for VLANs for uplink. And this is going to give me a nice, predictable, and easy to set up configuration that allows me to drive traffic to different uplinks, different VLANs perhaps, across different NVDSs. Now, by contrast, I could simplify the host switch configuration, and this is gonna make my uplink profiles a little bit more complex, but I can get the same kind of behaviors out of a single host switch configuration, and take advantage of everything there. Now, VMware is going to lean towards this single NVDS solution because it's fewer virtual switches to worry about. But again, this particular configuration does have an impact on how we're going to build out our uplink profiles a little bit. We can also take advantage of smart NICs, of DPUs on the edge. There's actually a toggle when I deploy an edge. If I have smart NICs in my hypervisors, there's a toggle on the edge that says, use UPT for pass-through, so that we can pass that network device directly off to the smart NIC. This is a really, really great feature that allows us to accelerate all of the NSX capabilities, even on a virtual edge. Now, a bare metal edge is functionally the same, but we're installing the edge software onto a piece of hardware. Instead of using a virtual machine, we're using a physical server. And we can see the recommendations and requirements, minimum requirements for compute resources here. Something like our recommended requirements, that's going to be much easier to find in the modern data center. It's kind of tough to find a server with 8 cores and 32 gigs of RAM these days. It's not that they're not out there, they're just less common. But if we're driving to a bare metal edge, that probably means we have some pretty significant resource requirements, some pretty significant packet processing requirements that we're trying to meet. So having more compute requirements to process those packets is always going to be a good thing. Now, in order to deploy a bare metal edge, I need to make sure that the hardware is on the compatibility guide, that the network adapter, very specifically, is on the compatibility guide, and we've got that spelled out actually again in the installation manual. So in the install guide, you can go and look, and we'll list out the specific network adapters that we support. And there are a few CPU capabilities that we need to support that most of our modern processors in the data center tend to support anyway. AES-NI for encryption acceleration, huge page support, those kinds of things. Now, many of these requirements, if we look at this, these requirements really look very much the same as what we just talked about with the virtual edge, with our SHA-512 encryption for the password, if we're PXE booting, and things like that. Because in both cases, both sets of requirements are really focused around a manual installation of the edge rather than the automated virtual machine installation that we can do through the NSX UI. Now, the NSX UI, if we're deploying virtual edges, that's the way to go. This is the easy way to do it. We'll automate not only the deployment of the virtual machine, but also the configuration of NSX. If we're not going that route, if we're not using the NSX UI, a virtual appliance deployment through vCenter, an OVF deployment through vCenter using OVF tool, that's going to kind of automate the deployment of the virtual appliance, but then we have to manually configure the edge as a transport node. We have to manually join the management plane and then configure the transport node characteristics. If we're deploying through an ISO image into a virtual machine or to bare metal, the same thing applies. We're deploying the edge software, but we still have to integrate that edge software with NSX. Now, going through the NSX UI is really, really straightforward. If I go to the System tab and expand out the Fabric header in the navigation menu on the left and go to Nodes, there is an Edge Transport Nodes tab right there and an Add Edge Node button that I can hit, and I can fill out a wizard with information about the edge node. Where do I want to put it in vCenter? How do I want to configure this as a transport node? And off we go. So, here we see the beginnings of that, where I give the edge object a name. I define the size, the form factor of the virtual edge. And then I can go through and define where in vCenter I want this, what cluster, what resource pool, and so on and so forth. What management network am I attached to? And then I can start building my host switches. I can start building my NVDSs and configuring the edge as a transport node. And I'm going to deploy one or more host switches to go ahead and allow for communication in and out of this edge transport node. My host switches are going to be members of an overlay transport zone and a VLAN transport zone, because I'm going to need to be able to communicate with both types of networks, right? The overlay networks for my NSX logical switches, and my VLAN networks for connectivity to my upstream routers. Now, deploying through vCenter Server, if I'm just deploying the virtual appliance, I'm going to walk through the Deploy OVF template wizard that I'm going to find by right-clicking on a host or a cluster or my data center object. And I'll simply step through that wizard and configure host names and management IP addresses and things like that. PXE booting, well, if I've got a PXE infrastructure, I can integrate the ISO image for the edge transport node and boot my virtual machines or bare metal servers as PXE clients and install the edge software that way. From an ISO image on a bare metal server, whether that ISO image has been burned to a CD and installed into an optical drive, or has just been loaded into the virtual optical drive through the baseband management controller, we can install NSX that way as well. We're probably going to choose the automated install here. For all of the deployment methods except deploying through the NSX UI, I'm going to have to manually join the edge transport node to the management plane. And that's done with the join management plane command, as we see here in the bottom screenshot, the join management plane, the IP address and credentials for the manager, as well as the certificate thumbprint. And I can get the thumbprint from the NSX manager. I have to log in, I have to SSH in to the virtual machine console, and I can use the command get certificate API thumbprint, and then copy and paste that into the join management plane command on the edge node itself. Once that's done, that edge node will show up in my NSX UI, and then I can use the NSX UI to prepare that that edge node as a transport node, create the NVDSs and assign my tunnel endpoints and things of that nature. Any way we deploy the edge, once it's done, once it's all ready, this is going to look like pretty much like any other transport node. I can see in my edge transport nodes the name of the edge device. I can see that my configuration state is successful. I can see how many host switches or NVDSs I have configured. I can see the node status. I want the node status to be up. If I hit the little information icon, I want my manager and controller connectivity to be up. My physical NIC, my tunnel status, all to be up. Right. This is what it should look like when it's all said and done. Now, I can, after I deploy for virtual machines, go in and change resource reservations. Now, I wouldn't do this just normally, right? This wouldn't just be part of my typical deployment. I normally want to leave the virtual appliance alone. But if I'm in a lab and I don't need all the resources, or I don't have the resources to reserve, maybe I can dial them back here. Or if I'm working with VMware support on maybe a performance problem, maybe they'll have us tweak the resource reservations. But that's the kind of case where we would get into this. This can be done. It's probably not something we're going to do regularly. Now, something we may do on bare metal or virtual edges is change other node settings, enabling SSH, for example, or changing the host name or the DNS servers, things of that nature. This is also where maybe I could enable pass-through support for the edge for my smart NICs. Maybe if I have, say, upgraded from a previous version of NSX to NSX4 and my hypervisors are now vSphere 8, and I have SmartNICs installed. Maybe I want to add SmartNIC acceleration to my edges after the fact. I can do that through my node settings here in the Actions menu after I select a given edge. We can also, during the edge deployment, enable uniform pass-through. And so this is a simple toggle on the node settings on my deployment wizard. Right, I can just turn this on here. So if I'm deploying a new edge onto a SmartNIC enabled hypervisor, I can enable uniform pass-through on the edge itself. Now, once we've got the edge deployed, whether it's a bare metal or a virtual edge, it doesn't matter, we can go through this checklist. And what we're really doing here, if we look at all of these things, is validating that the management network is set up, right? And that's really the only thing at this point that we can check, because we don't have, we don't have any routing set up. We don't have any routing components deployed. We've simply deployed the edge transport node. So this gives us the opportunity to validate, can I SSH into the device? Can I ping my gateway? Can I ping my time server? Can I get to my DNS server? All that kind of stuff. That makes sure that our management interface is all set up and ready to go. Now, once I have at least one edge node deployed, probably more than that, I'm going to build an edge cluster, and I can go from the edge transport nodes tab to the edge clusters tab and simply create the edge cluster. It's a really simple process. I hit the add edge cluster button. I give the cluster a name, and then I simply add the edge transport nodes in that I need to add. That's all there is to it. Once I'm done with that, I hit the add button and off we go. We have an edge cluster. Now, let's make all of this happen, right? We've talked about this. We're going to deploy two edge nodes, SA NSX Edge 01 and SA NSX Edge 02. We're going to do them one at a time, just to make sure that we have enough resources in our lab to do things, right? Sometimes, depending on what all's going on in this big shared environment, we might run into a touch of contention. So we want to do things serially so that we know that they're going to deploy okay. We're going to deploy these two edge nodes. It's going to take a little bit of time, and then we're going to build an edge cluster. That's not going to take us much time at all. So let's take a little while, go through and deploy these two edge nodes, create the edge cluster, and then come back. We'll wrap this lesson up. Okay, so took a little bit of time. not too much, but a little bit. And that was not the most exciting lab. We kind of watched a progress bar for a while, and sometimes that's what we have to do. So we've got our edges, we've got our edge cluster for our lab. We're almost ready to get into building gateways themselves. Now, what did we do? We talked about our edge nodes. We talked about what they are. We talked about bare metal and virtual edges. We talked about building our edge clusters and sizing our edge nodes for different uses. So, that's our edge nodes. That's our edge clusters. If you come back and watch the next video, we're going to talk about configuring up our tier 0 and our tier 1 gateways now that we have edge clusters to work with. Can't wait to show you that.